Today we're going to find the midpoint of a segment. Let's say we want to meet halfway. Halfway is the midpoint. And a midpoint divides a line segment into two equal parts, or a 1-to-1 ratio. We call that bisecting a segment. So in this example, each individual is 10 feet away from the halfway point or the midpoint. We can find the midpoint in a couple of different ways in coordinate geometry. I'm going to show you both. The first is a very geometric approach. Let's find the horizontal distance between the 2 points P and Q. To find that, we would subtract 1 from 7 and get 6. Take half of that, which is 3. Let's do the same thing vertically. The vertical distance between the points is 4. Half of 4 is 2. Now we're going to start at point P and move from point P horizontally 3 spaces and 2 spaces vertically to reach the original line segment PQ. And our midpoint is at the ordered pair 4, 4. The method I just showed you is going to be very important when we partition line segments, not halfway. Maybe we need a point a fourth of the way, or a third of the way, or 2/3 of the way. That method is going to be what we use. However, for midpoint, there is another method, and it involves averages. If we average the x coordinates and average the y coordinates, we're finding halfway in between. Let's look at the original diagram, and we're going to average in red at the bottom the x coordinates. That means I add up the x coordinates, 1 plus 7, and divide by 2. I'll do the same thing vertically. Add up the y coordinates, 6 plus 2, divide by 2. In both cases, we got 4. That's exactly the midpoint. That is the midpoint. So instead of moving a certain number of spaces to find the midpoint, this formula actually calculates the midpoint directly. Let's practice. Midpoint formula. We add the x coordinates, divide by 2. We add the y coordinates, divide by 2. A midpoint is an ordered pair, so it's inside of parentheses and a comma in between. This formula works for all types of segments, vertical, horizontal, or diagonal. Example 1. We've got 2 ordered pairs. Here's the midpoint formula. We're going to sub in the x coordinates, 4 plus 1, and divide by 2. Then we will sub in the y coordinates, 8 plus 12, divide by 2. When we simplify, we get a midpoint of 5/2, 10. You could pause the video right now and try example 2 on your own, and then press play when you're ready to check. Point A, point B. Here's the midpoint formula. Add up the x coordinates, divide by 2. Add up the y coordinates, divide by 2, and simplify. Here our midpoint is 1, -1. This example has us work a little bit backwards. We are asked to find the coordinates of one of the endpoints given the midpoint itself. So let's set up our midpoint formula. We were given the midpoint, and we were given the second endpoint. we will use x1 and y1 for the coordinates of x, which is what we've been asked to find. From this, we can set up two equations. The first equation will allow us to solve for x1. To solve this equation, we'd multiply both sides by 2, and then we'd subtract 2. Second equation. To solve, we would multiply both sides by 2 and subtract 8. The endpoint x has coordinates -6, -4. Looking ahead, the midpoint formula can be used to help us classify geometric polygons and their properties. The midpoint formula specifically helps us determine if two segments bisect each other. And just a few of the bisecting properties we know already include the fact that diagonals of a parallelogram bisect each other. Diagonals of a rhombus bisect each other. Diagonals of a rectangle bisect each other. Those aren't the only properties involving bisection. We'll see more in the upcoming lessons.